So we're going to skip over part one of the implementation because that's just walking through the Quotes Connect controller and Quotes Connect service. And we've already covered that in previous lessons, so there's no sense in repeating it. What I am going to talk about, though, is the messaging portion of the RSocket Shakespeare Quotes app responder. So that's the part that handles the messages, and it's also going to show how to access the R2DBC database that stores and retrieves the Shakespeare quotes. And as usual, you can get this in my GitHub account in the EX3 project RSocket folder, live lessons GitHub repository. So here we are over in the quoter package in the EX3 project in my RSocket folder in the live lessons GitHub repository. And this is just the message controller, the quotes message controller, and it demonstrates a bunch of different interaction models. It's got a quotes message service that's wired. A couple things here that I'll just mention because we do use them in the examples. There's a method that gets the number of quotes, and I'll show you how to do that. This is the total number of quotes in the database, and it turns out that there's just a nice little database method to return that, so you don't have to do anything special for that other than forward it to the service. There's a way to subscribe. There's a way to cancel your subscription in both an unconfirmed and confirmed way. There's a method that gets all the quotes, that will get you all the quotes entirely. There's a method that gets the quotes that you're requesting here, and this is the request that you send. It's the random request. We'll talk about that later. So those are basically what we have in terms of the controller methods. Reasonably the same as what we did before. There's a few little tweaks, but more or less the same. Here's the implementation. This is the quotes message service. We've got our quote repository, which we'll take a look at. We've got our subscription set, which we'll take a look at. And then here's get number of quotes. You can see get number of quotes just turns around to the quote repository and says, please give me back the count of the number of elements in the repository. So that's all there is to it. There's a method that gives you the number of elements, or in this case, the number of Shakespeare quotes that are in the database, and there should be 100. Here's subscribe. Subscribe takes the subscription request, and much as we looked at before, makes a new subscription response, which is confirmed, and it has the Shakespeare play that we care about if we want one. And then we go ahead and add that to the subscription set, so we keep track of the fact that that subscription is subscribed, and then we return the subscription response. The client is then, or the requester is then free to unsubscribe either in a way that does not require any confirmation, there's no response that comes back, it's a void, or it can do it in a way that you get back a confirmation that the subscription was canceled. The main point here is we take the thing out of the subscription set, so not a whole lot of deep, insightful stuff there. Let's take a look at get all quotes. So get all quotes takes a subscription request, and assuming it's a valid subscription request, it goes ahead and calls the find all by play Spring Data API method on the quote repository. And you can see here, if we go over to the quote repository, here's the reactive quote repository. It's got two methods that we define, and also the ones that come along for the ride, like count, for example. And you can see here, this finds everything by play, and then the other one is find everything by the list of query IDs. So those are the two methods that we define. And once again, it's cool because we don't have to write any code. We just have to write the method definitions. Here's the other method. This is the one that gets the random requests. So you can see we come in here and we get the subscription from the request. Oh, by the way, here's what the random request is. Random request is a record, Java record, that has a subscription and an integer array of random indices. And this illustrates that you can send records around quite nicely using Spring. So this actually gets passed from the requester to the responder as a so-called DTO, a data transfer object. So once we get the subscription, we check again to see if the subscription is subscribed. If it is, we go ahead and return a flux containing all the quotes that correspond to the random indices that were sent from the client. So that way we can get random quotes back. And if we're not subscribed, we return an empty flux. So that's a quick walkthrough of the quotes messaging service and controller. Not much change from last time, with the main exception being that we're using this R2TBC repository to get the quotes rather than what we had done before, which was put them in a list. By the way, here is the actual data. And as I mentioned before, these are the famous quotes that ChatGPT generated for me. Very, very kind of it to do that. And I asked it, it was kind of interesting, again, showing how you have to be careful when you use ChatGPT. It has limits on token output. So the first thing I did, I said, please generate me 100 famous quotes from Shakespeare and put them into the data SQL format with the play name followed by the quote. And it generated a bunch of stuff. But after about 50 or so, it stopped because it has a limit on how much data it can generate. So I was like, aha, I know how to solve that problem. So I used the, I think it's called the like iteration pattern or something like that. And I went back and I said, please generate me 100 quotes, 25 at a time, and stop and ask me before you generate the next 25. And so that way it was able to do that in 4 chunks. It generated the first 25 in this format you can see here, and then it stopped. And it said, would you like me to proceed? I said, yes, please. And then it generated the next 25. So all I had to do then was just cut and paste this stuff, and it worked pretty good. Now, there was one funky thing, which I have to mention. This is bizarre. So it turns out, for various reasons, that if you have semicolons in the input you give to the database mechanisms, for some reason the parser gets confused and thinks that's the end of a statement. And it's very weird. It's rather hard to track this down, and the suggestions I got from ChatGPT were not helpful. But I found out if you put this wacky syntax in here, if you have something that's a semicolon, which Shakespeare has a bunch of semicolons, Shakespeare quotes. So you have to say concat, you give like the first part of the string, care 59, which means semicolon, followed by the rest of the string. And you write it like that, then the parser can deal with it properly. Completely bizarre, very strange. Clearly they weren't prepared for Shakespeare quotes when they came up with their parser. But that's the way to work around that. So that was a little bit of lesson learned that I was surprised to have to figure out, but I got it all working.